Okay, so I wanted to go over the Icyhot diagrams just to make sure, and the bar graphs, that you guys are okay on those. All right, so I hope you can, I don't know if you can see this. Use the pen. Okay, so remember, this part is solid. Okay, at A. B is the transition from solid to liquid, okay, which we would call melting. All right, D to E is a full liquid. Okay, F to G is going liquid to gas, and that's what we would call boiling. Okay, and then H would be a full gas. All right, so on the diagonals, there is a temperature change, okay, which was an ETH. Temperature change, okay, particles are getting faster. Right, the particles are getting faster when there's a temperature change on the diagonals, on the ETH, okay? On the flat parts, there is a phase change, EPH, okay? The particles are at the same speed, right, because there's no temperature change, but they're changing arrangement. Okay, so this is like what I'm going to want you to put in the CER, okay? So this is going to be close to what your claim should look like. Okay, right? Your claim would be that when I add energy to a system, I know these should be labeled, right? This is a garbage graph. Energy, temperature, all right? When I add energy to a system, it can either increase the thermal energy, okay, by changing the temperature and making the particles get faster, okay? Or it can change the phase energy by changing the arrangement, okay? The temperature is constant at this part, all right? So the speed does not change, okay? All right, so that's kind of what your claim should look like. I want you to talk about the ETH, the thermal energy, and the phase energy, all right? And they do not happen at the same time. All right, that is the important part. It's either one or the other, okay? And this is what's also in those readings. You can reference those readings too for help, okay? All right, so what I'm looking for in your diagrams, right, is like A, I think we drew 8 when we drew it in class, all right? There are particles with one wiggly. These are really hard to draw in here. Okay, so this is going to be a solid with one wiggly, all right? And remember, this was a temperature less than 0, because for water, this is happening at 0, this is happening at 100, all right? So when you go to draw your diagrams, your thermal, right, remember we said 1 bar was 0, so it's like somewhere below, okay? And it's a solid, so it's gonna get 1 box of phase, all right? On B is part of the transition from solid to liquid, right? So I should see some particles still as a solid, and some are sort of breaking apart into being a liquid, all right? It's a little warmer because see, A is at this temperature, B, C is at this temperature. So it's a little bit warmer, so I'm going to give it 2 wigglies. 1, 2, 1, 2, 1, 2, 1, 2. They're very hard to draw in here. Okay, yours can look better than this. All right, and I am now at 0 degrees Celsius. All right, and I'm a solid, but now I'm on the way to becoming a liquid. So I'm going to make that a touch higher. All right, so the important thing is there's an increase in boxes, right? There's an increase in boxes because I'm adding energy into the system, okay? All right, when I go to C, you can't really see it on here, so I'm just gonna draw it over here, all right? C is at the same temperature, all right? So when you draw the one for C, it's still at 0 degrees Celsius. The temperature hasn't changed, but I'm adding energy, so now I'm gonna have a little bit more, but not quite to 2, right? Because that would be full liquid. All right, so when I go to C, I've added a little bit to there, right to there, okay? This should be the same in C because the temperature did not change because it's on a plateau, okay? Same thing from F to G, right? When I get to there, that should stay the same, all right? Okay, all right, let me pause so I can get, well, let me do this one, I guess. All right, so F to G, see, that's another transition. That is the boiling transition, all right? So this is where I'm gonna have mostly liquid particles. 1, 2, 3, 4, 5, 6, and then a couple are splitting to gas, All right. So I think this was the one where we ended up with 5 wigglies, I think, by this point. 1, 2, 3, 4. Yeah. Okay. So 5 wigglies. Okay. 1 whooshy. All right. So that has a whooshy, 1 whooshy, 5 wigglies. These are all the ones that we drew in class. Okay. So these should look really great. All right. By the time I get to F, all right, my temperature is at 100. Okay. Because it's at the boiling point of water. And my phase, some of it's a liquid, okay, but some of it's a gas, right, which would be 4. So I'm going to be somewhere in this transition. I'm going to be somewhere in this transition. All right. When I go to G, right, G is going to look exactly the same because the temperature didn't change. But in G, I'm going to add more to the phase because this is during the phase shift. All right. So this is during the phase shift. Okay. All right, I'll let you figure out D and E. I think that'll be okay. All right, let me pause this and go to the other one. Okay, so here is the backside with the lauric acid, all right? And this one is going to be, this is what we wrote in class. Oops, hold on, I need the pen. Okay, this was a gas. Oh, that's a boring color. All right, this was the gas to liquid transition, which we said is called condensing. Or condensation, condensing, okay? D to E, fully liquid, okay? F to G, liquid to solid, which we would call freezing, okay? And then H is a full solid, all right? So this is exactly like the other side, but just backwards, all right? So at A, right, you'll start with probably above boiling, so I would make it more than 4. All right, and it's a full gas. All right, and then by the time it gets to B, it's a little lower temperature, so it's more at like the boiling point now. All right, and it's not a full gas. Some of it is turning to liquid now, so it's going to be a little bit less. All right, and then as I go to C, right, the ETH should stay the same, right? So for C, it's going to look same like this for C, but now this is going to be even lower, but not all the way to liquid yet. Okay, that's going to be lower. Then this is going to be all the way to liquid, liquid, and then it's going to be the transition here to solid. Okay, all right. So the important things that I need to see, all right, is during the diagonals, there's an ETH change, right? So in this case, since energy is being released, this is the particles would be slowing down. Okay, here in the flat part, there's a phase change. This would be the particles should get closer, right? They're turning to liquid. They're turning to liquid. All right, on this diagonal, again, there should be an ETH because there's a temperature change. Again, the particles are slowing down, right? That's where it'll be losing wigglies or, yeah, I guess because it's liquid, losing wigglies. All right, on this part, there's a phase change, okay? Again, particles are changing arrangement and getting closer because they're becoming a solid, okay? And then here, again, there's a temperature change. The particles would be slowing down, okay? So that's the main big important idea that I need to make sure that you show me in your lab report and on the quiz. There's a temperature change on the diagonals, okay, that's changing the thermal energy. In this case, the particles are slowing down. When it's like this kind, okay, then on those ETHs is where the particles are speeding up, okay, ETH, 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 okay, and then on the, it's a nice color, how about this? All right, on these flat parts, here and here on the plateaus, that's where there's a phase energy change, okay? But the temperature is constant. Same thing here and here. There's a phase energy change, okay, where the particles change arrangement, but they do not change temperature. Okay, oh, this is hard. Same temperature, right? Same temperature, same wiggly, same everything. The only thing that changes on the flat parts is that the particles are either getting closer or further apart. Okay, all right, one more thing I want to talk about. Okay, so in your CER, I don't think I can write on this, no. All right, your claim, right, should address, here, let me just, hold on, let me make a thing. All right, so here, now I can write on it. Oops. Okay, it's going. Okay, all right. For your claim, right, this is where I want you to talk about what happens to the energy of the system and the particle behavior when energy is added through heating. Okay, there are two accounts, all right? So the two accounts I'm talking about are the thermal energy account and the phase energy account, all right? So when I put energy in, you can just talk about in the claim if you want, and then talk about out in the reasoning is fine, okay? When I put energy in, it goes into one of two places. It either goes to the thermal account, so it changes temperature, okay, and the particles speed up, okay, or it changes arrangement of the particles, and there's a phase change, solid to liquid to gas, all right? So whenever I put energy in, one of these things happened, but not at the same time, right? It kind of takes turns, not at the same time, okay? All right, for evidence, we didn't have much since this whole lab kind of got messed up. Okay, we don't really have a whiteboard photo, but you could explain the graph, right, that you have on your sheet, okay, right? And what you need to explain in your graph is you can say, I saw when we heated water, it made this graph. On the diagonals, there's a temperature change, okay? And then on the flat parts, there was a phase change. Okay, so you could connect that to like what you saw in the lab. You could say, I saw ice, right? Then you saw that it was melting. Then you saw water. Then you saw that it was boiling. Okay, we didn't see this part, all right? So you can connect what you saw in the graph, right? Because remember, we only saw like this middle part of it, right? So we saw ice, then you saw, you saw ice and water melting, then you saw just water, then you saw boiling, okay? Right, so that's what I want you to put in evidence. And it's okay if you don't have a photo, it's fine, just you can describe the graph, it's okay. All right, and then for reasoning, this is where I need you to be able to explain it, all right? So I want you to be talking about what's happening to the particles. They're either speeding up or they're changing arrangement. I want you to make sure you talk about thermal and phase energy, okay, and exactly how they're changing, all right? They're either changing arrangement or they're changing speed, okay? Then I want you to talk about the heating curve versus the cooling curve. What's different? What's different in the cooling curve than in the heating curve, right? So this one, when energy is coming out, okay, which we could call exothermic, right? If you want to go back to the words, all right? And then on the heating curve, that's when the energy is coming in. That's an endothermic process. It's taking energy in to make that happen, okay? Right? You can use those readings that I gave you, but please use your own words. Don't copy the readings, okay? You can use your own words, but I basically need you to describe this whole thing. That's what I want to see in reasoning, okay? All right, so claim, make sure you talk about ETH, EPH, and what happens to those particles. All right, evidence, you're going to explain this graph a little bit, just what you saw, that you saw ice, you saw it melting, you saw water. And then reasoning, I want you to describe all of what's happening to the particles and talk about the particle diagrams, okay? You can talk about the energy bar chart too if you want in reasoning. No third one. Okay? All right, if you need any help, come and find me on Tuesday, all right? Or you're welcome to email me as well. Thank you.